Good morning, everybody. My name is Sai Kiran. My topic is multi-operator spectrum sharing for massive IoT coexisting in 5G B5G wireless networks. Introduction: with the significant development of wireless networks, tens of billions of IoT devices will access the next generation mobile communication. Fifth generation or beyond 5G for realizing advanced applications such as smart city management, unmanned environmental monitoring, and collaborative intelligent transportation systems. According to the recent IoT report, up to 20.8 billion IoT devices will be used worldwide by 2020, and the IoT market will be over 3 trillion annually by 2026, which is due to the increased industry focused and the IoT technologies from the third generation partnership standardization. As the access number of IoT devices explodes in 5G wireless networks, one main challenge for mobile network operators lies in accommodating the fast growing traffic services generated by both high speed cellular users and massive IoT devices over limited radio spectrum. Considering the high quality service guarantees and cost issues, recent such reports that for a typical European cellular operator network sharing could reduce more than 50% of infrastructure cost. Sharing architecture named active run sharing, in which a master operator was designed designated as the only entity to manage the operator was designed entity to the managed resource shared among the participating operators. Despite its great potential, the network sharing would significantly increase the implementation complexity of wireless systems for multiple MNOs. How to quickly access a large number of cellular users coexisting with massive IoT devices and allocate the required spectral bandwidth. Them a multi operator spectrum sharing architecture is still an open problem. Different from conventional spectrum sharing among cellular users, there are two main characteristics of the spectrum sharing spectral users. There are two main characteristics of spectral sharing of a massive IoT devices in 5G wireless network. The first characteristic lies on the traffic model. Conventional spectrum sharing technologies are mainly developed for downlink long packet communication from a base station to mobile devices. However, the future spectrum sharing of IoT device wireless networks will be dominated by uplink communication end devices to the base station, which requires a scheme design of spectrum sharing of massive IoT devices to consider the real-time massive uplink traffic distribution. The second characteristic lies on the IoT device class. The massive IoT devices are expected to be cheap and thus usually have limited signal processing capability and unrechargeable batteries. This difference requires simple and efficient scheme designed for IoT spectrum sharing to reduce both the scheme computing complexity and energy consumption. Based on above consideration, we investigate his multi-operator spectrum sharing problem to support the coexistence of a cellular users and massive IoT devices with the guaranteed quality of services. In conclusion, in this paper we have investigated a multi-operator spectrum sharing problem to support the coexistence of massive IoT devices and cellular users. Specifically, we have presented a Stackelberg pricing game framework to model and analyze the joint cyclic dynamic decision making problems among the WSP MNOs, cellular users, and IoT devices. The MNOs can maximize the payoffs by purchasing the optimal bandwidth to maximize the access number of cellular users and IoT devices, and the WSP maximize its payoff by attracting more bandwidths requests from MNOs. The cellular users and IoT devices can access the networks and be served by the MNOs based on proposed coexisting access rules. Based on the formulations, we have proposed an iterative algorithm for the Stackelberg precising, which can reach the equilibrium through iterating on WSP's bandwidth price. Furthermore, theoretically analyzing and simulation results have proven that purposed algorithm can converge to the Stackelberg equilibrium. In future work, we will consider the spectrum multiplexing among the MNOs and applies NOMA technology to maximize the coexisting numbers of access Internet of Things devices to further improve the spectrum utilization.